Hello, my dear student. I learn Kumar, senior PGT in DAV, Jharkhand Zone E, with physical chemistry in the topic electrochemistry. Very interesting and easy chapter. Some recap about electrochemistry. The first I am starting. That is the cell, electrochemical cell, the Daniell cell, galvanic cell, voltaic cell. How we can represent cell and cell reaction. As we know that EM of the cell is equal to E right cell minus E left cell. A standard EM of the cell as well as electrode potential of the right cell, standard electrode potential of right cell minus standard electrode potential of the left cell. The left cell. Very important topic is the Nernst equation. The electrode potential at any concentration measure with the respect to the standard hydrogen electrode, that is SHE. EM of the cell is equal to a standard EM of the cell metal ion minus RT by number of the electron transfer and gaining by F ln concentration of the metal by concentration of metal ion. That is your electrode potential is equal to a standard electrode potential minus 0.059 by number of electron log concentration of product by concentration of reactant. And we can also write in the general equation form, just like AA plus BB, product will be CC and DD. Then E of the cell is equal to a standard E of the cell minus RT by NF ln concentration of product, that is concentration of C and concentration of D by concentration of A and B. Another topic which is also important, equilibrium constant from Nernst equation. EM of the cell is equal to minus 2.303 RT by NF log Kc. This is log Kc equilibrium constant. Electrochemical cell and Gibbs energy relation. And for general equation, for simple equation, when zinc react with the copper ion, they will convert into zinc ion and copper. And a standard that Gibbs energy of this reaction is equal to minus NF EM of the cell. If the concentration of the reacting species is unity, then EM of the cell is equal to a standard EM of the cell. Then we can also write Gibbs energy in this form. Gibbs energy of this reaction is equal to minus NF standard EM of the cell. We can also calculate equilibrium constant by this equation. Gibbs energy of the reaction is equal to RT ln K. Second part of the chapter, that is the conductance and conductivity. As we know, conductance, which is the reciprocal of resistance, G is equal to 1 by R, and its SI unit will be per ohm or mho or Simon. Conductivity, that is its symbol will be kappa. Kappa is the reciprocal of resistivity, that is 1 by rho, and its SI unit will be per ohm per meter, Simon per meter or Simon per centimeter. And another topic, that is molar conductivity, and molar conductivity is equal to kappa by C, and SI unit will be Simon meter square per mole. And we can also write kappa by 1000 into molarity. What do you mean by limiting molar conductivity? Very important topic. They will come for 1 marks. The limiting molar conductivity, when concentration approaches to 0, the molar conductivity is known as limiting molar conductivity. And we can classify the electrolyte in the two types. A strong electrolyte, that conductivity is equal to a standard molar conductivity minus A into concentration to the power under root concentration. Example, NaCl, CaCl2, magnesium sulfate are known as 1,1, 2,1 and as well as 2,2 electrolytes respectively. In that strong electrolyte, we can also write here one simple law, that is Kohlraasch law of independent migration of ions. Limiting molar conductivity of an electrolyte is the sum of individual contribution of cations and anions. That is, the limiting molar conductivity of NaCl is equal to individual conductivity of sodium ion plus individual conductivity of chloride ion. Again, I am starting another topic, that is electrolysis. Electrolysis. That is, in that electrolysis we discuss about another law, that is Faraday law. And this Faraday law, the amount of substance deposited or liberated at any electrode is directly proportional to the quantity of electricity passes through the electrolyte. That we can also write mathematically, n varieties Q. Q here it is charge, and we can write Q is equal to I into T, and M is equal to Z into I into T. Z is a constant. That is also called electrochemical equivalence. Second law, if the same quantity of electricity is passed through different electrolyte connected in series, then the weight of the substance produced are directly proportional to their chemical equivalence, and we can write in mathematical form W1 by W2 is equal to E1 by E2. Another topic, what should be the product of electrolysis? Product of electrolysis depends upon nature of the metal being electrolyzed and type of electrodes which is used, and whether electrodes are inactive electrodes or active electrodes. If we are taking platinum as electrode, it is an active electrode. If we are taking graphite as electrode, it is an active electrode. You see the simple example like NaCl. If it is the molten phase, it after electrolysis it gives your sodium and chlorine. But when NaCl in the molten phase, when NaCl in the aqueous phase, after electrolysis they will provide NaOH, H2 and Cl2. This means nature will be changed, product electrolysis will be changed. Last topic which are in this chapter, that is your battery, and we simply know that battery is of two types, primary cell and as well as secondary cell. Primary cell, that is also your like Lance cell. Here we in this cell we use anode like zinc, and cathode is made of copper, and electrolyte will be ammonium chloride, magnesium dioxide and zinc chloride, and anode oxidation will be take places and cathode reaction will be take places. And one other topic for the objective pattern, objective question, what is the button cell? Button cell where anode is made up of zinc amalgam, ZnHg, and cathode is made of mercury oxide, which is used in the different hearing aids like equipment. Secondary cell, it is also called lead accumulator cell. In that secondary cell, what is the electrode in which substance electrode is made up of? The anode is made up of lead and cathode is made up of lead oxides. Electrolyte will be 38% H2SO4. Here a student should be take care whether battery is in use or battery is in charging. The first I am discussing about battery is in use. At anode, oxidation will be take places. This lead react with the sulfate ion, convert into lead sulfate, and they will release electron. And at cathode, lead oxide react with the sulfate ion in presence of H plus ion, and they will accept electron and convert into lead sulfate and water. And overall reaction will be lead plus lead oxide plus sulfuric acid. Product will be your lead sulfate and water. So here we can write both as well as using, this means charging and discharging both. And another cell which is also in, that is nickel cadmium cell, but it is not in your syllabus. At last, here it is a fuel cell which is more efficient in compared to secondary cell, and as well as electricity provided by thermal plants. And in that cell, but it is not generally used, it is used and as a space satellite. Here H2 and oxygen will be used. Electrolyte like NOH will be used. And last topic, your corrosion, which is also based upon the, this means corrosion means slowly coats the surface of metallic object with oxides and other salts of metal, the rusting of iron, tarnishing of silver, development of the green. So these are methods by which we can avoid rusting, avoid corrosion. And it is also example of electrochemical reaction. And in one point, it act at a particular spot, they will act like as a anode where oxidation takes place. Another point it like a cathode where reaction takes place. And over all reaction, iron plus oxygen in acidic medium, they will provide your ferrous ion and water. So here I have recapped this chapter, and I think a student will be benefited from this topic, and they can use their time, and they can solve more and more questions. And numerical based chapter, this is a numerical based chapter, and numerical completely based upon the Nernst equation, how we can find out the EM of the cell, either Gibbs energy or equilibrium constant Kc we can find out. And some numerical also based upon conductivity, molar conductivity, and And objective question like how much charge is required to convert, just like aluminum ion to aluminum, copper ion to copper, magnet MnO4 minus 2 Mn plus 2. How much electricity is required to in coulomb for the oxidation of 1 mole of water to O2, 1 mole of FeO to Fe oxide, ferric oxide. That's all. Next topic I will discuss about that is your chemical kinetics.